In the previous scenario, 1A, we determined an order size. Q equals 500. Very often, once you've appointed some certain order size, your policy, you then follow up with a certain amount of analysis to learn about the implementation of this policy. That's essentially what's going on with these questions. Let's look. Consider scenario 1A. We were just remarking. Some employees are worried that, there it is, that's what we decided in scenario 1A, Q equals 500 will result in too few book bags available for sale at the park. Okay, if Adventure Center makes this change to Q equals 500, what is the maximum number of book bags that would ever be available for sale? That is super easy to answer. Now, taking you back, scenario 1A, Adventure Center is ordering these book bags 1,000 at a time. We did some analysis and said they'd save money if they'd order them 500 at a time. Okay, fine. If they order them 500 at a time, what is the absolute most that there would ever be in inventory? In this situation, max inventory couldn't be easier. It's just the size of the order. Oh, so the answer was actually given to us at the beginning. It is 500. Now, if you're looking at that and you're saying, well, okay, that's great, but why? Remember the theory behind this. The theory behind this is you're going to place that order so that it arrives just when you run out, when Adventure Center is completely out of branded book bags. That means the order lands all at once, right, on your loading dock. It arrived. That's your maximum inventory, because at that point you start selling off branded book bags. Your inventory is only going to be some number lower than that. Oh, okay, now that's your maximum, what it spikes out at. What about, next question, what is the average inventory of book bags that would be available for sale? In this situation, average inventory isn't that much more complicated. Take Q, the order size, and divide it by 2. That's it. Oh, okay, so in our case, on average, how many branded book bags would they have sitting around? 250. And that answers that. Oh, okay, well, we're on a roll. Let's look at this last one. How frequently will book bags need to be ordered? Now, there's a couple different ways that you could answer this. The first one, like most intuitive one, is okay, well, if they're ordering them 500 at a time, how many times a year will they order? That's real easy to answer. Orders per year, because that's just D divided by Q. Okay, now taking you back to when we were working on this, they use, D is annual demand, they use 5,000, they sell 5,000 branded book bags a year. We were told that earlier. Okay, so that's what goes in the numerator. The order size we're evaluating goes in the denominator. Right, it's actually just logic. If you need 5,000 over the course of a year and you're going to order them 500 at a time, you're going to order 10 times a year. Now wait, just before we go any further with that, because we can, if the Q divided by 2 and the D divided by Q look kind of like, deja vu, like I've seen that before, yes, actually you have. It's not asked here, but I'm sneaking it in. The formula for calculating the total cost of any order size is D divided by Q times S plus Q divided by 2 times H, right? This is the total annual ordering cost. This is the total annual setup cost. And this is not a coincidence. See this Q divided by 2? Average inventory? That's that right there. It's embedded in the total cost formula. That's where you've seen it before. And then see this D divided by Q here? It's not a coincidence. Oh yeah, if we think about it, that makes sense. You want to calculate the total annual ordering cost. Well, that would be the number of times you ordered a year times the cost per order, which is S. Oh, okay. Now, as far as addressing that one last question, how frequently will book bags need to be ordered? There is another reading that would be very useful. We know that they'll be ordered 10 times a year, but very often we're concerned or would like to know the cycle time. That is to say, well, fine, then how much time will pass between each order and between each delivery? Cycle time also addresses this question, and it's just that ratio flipped. Basically, in essence, Q divided by D. Oh, okay, now wait. First, just fill out the formula literally. 500 divided by 5,000. You get 0.1, right? You say 0.1, okay. What's that supposed to mean? Is that, now remember the Q divided by D is a length of time? Is 0.1 like a lot of time? Q divided by D, the number then that appears on your calculator, is in years. Why? Because the D is annual. Oh, okay, so we just discovered that if you order them 500 at a time, that a tenth of a year, 0.1 years, will pass between each time you place an order. Which is a true statement, and you could report that. If you actually literally reported that to somebody, they'd probably look at you a little strangely, because we don't normally talk about time that way, like what's a tenth of a year? You can take that number, the result of Q divided by D, and you can convert it into any other measure of time you want quite easily. For example, if Adventure Center, and I think they mentioned this in the extended scenario, is open year-round, okay? Then I'm going to assume 365 days in a year, because that's all of them. So I'm just going to restate cycle time, that's all. Cycle time is the original 0.1 years times 365, for 365 days in a year, 36.5 days. Oh, okay. I just found out that if we order these 500 at a time, oh, by the way, we are going to be placing an order every 36.5 days.